To add to your information for enzymes and proteins, we are going to show this graph one more time. And when concentration of substrate increases, there is a first order sort of rate of reaction. But there will be a point that the enzyme gets saturated and it becomes zero order. So once you have this flat line, you can calculate your Vmax. And that's the maximum rate of the saturated enzyme and its reaction with your substrate. Now, if you take this value and divide it by half, so once you come to half of Vmax, that, and you can go to your plot one more time, and you can interpolate, and you come to extremely important value known as Michaelis Constant. And that's the concentration of substrate and indicates the affinity of the enzyme for the substrate. Now, the smaller the Km is, the closer you are to zero, there is a stronger attraction or affinity between the enzyme and the substrate. So that's what you should sort of remember from Km. Why is it useful? Because it tells us at what concentration of substrate there is a strong affinity for the enzyme. So if Km is larger, then there is a weaker attraction or a smaller attraction or affinity between the enzyme and the substrate. Now we also have inhibitors. Those are chemicals that can interact with the enzyme and sort of make it obsolete or unreactive in the reaction. It's extremely important in medicine and drugs and medicine because sometimes we want to slow down a reaction of an enzyme and we use inhibitors. Now we have two kinds of inhibitors. You are either competitive or you are non-competitive. And it just depends on where you're going to bind to the enzyme. For competitive inhibitors, they have exactly the same shape as your substrate, and they have the shape that they can just go and lock themselves into the active site of the enzyme. So once you have competitive inhibitor, it can do the same sort of locking key system. It can go and just block your enzyme, and so the substrate cannot react with it anymore. Now, if you have non-competitive inhibitor, it doesn't go after the active site of your enzyme. It attaches somewhere else to this enzyme, and that site is usually known as allosteric site. Once it does that, it will change the shape of this enzyme or protein. Look at it here. It has the same shape as your substrate. Once the non-competitive has locked itself into the enzyme, it has changed it into a shape that your substrate cannot fit in anymore. So non-competitive will attach somewhere else on the enzyme. Competitive will attach to the active site of your enzyme. Now, what is their effect on the rate of the reaction? If you have competitive inhibitors, those that go after the active site, the Vmax does not change. It still has the same rate when the enzyme is saturated and its reaction with the substrate. So if you increase actually the concentration of substrate, you will reach to the same point. But when you have the competitive inhibitors, it will change the shape in a fashion that you see now you have a larger Km. So Vmax doesn't change, but Km increases. And this indicates now there is a less affinity between the enzyme and the substrate. If you have non-competitive inhibitor, on other hand, Vmax changes drastically. It gets smaller. So the enzyme saturation rate decreases. But it decreases in a fashion that when you look at the Vmax with no inhibitor and the Vmax in blue with a non-competitive inhibitor, they come and they give you exactly the same Km value. So there is still the same attraction between your enzyme and substrate. That doesn't change. And this is the case that whether you increase the substrate concentration or not, you cannot reach your maximum Vmax anymore. So it does not reduce the effect of this inhibitor, this type of inhibitor. So look at the graphs carefully, go back and forth to the vocabulary, make sure you know the difference between competitive and non-competitive, and also their effect on the rate of reactions.